PSGA is an interesting and powerful product. Now, unlike other products, it's not a member of a family. For example, in the case of an ER meter, if a customer says, I'm looking for an ER meter, you can say, yes, I have the General Photonics ER meter. It has 50 dB dynamic range. In the case of the PSGA, nobody's going to say, I'm looking for a multi-purpose PMD measuring system that does swept PMD, swept PDL, and can use as an analyzer and a generator. There's no equivalent to it. So we have to explain it to the customer. And the best customer to explain it to is someone who's in a laboratory environment running a lot of tests with PMD. It's an intimidating instrument to demonstrate unless you spend time with it. And for that reason, we're going to show you in this video in the next 5 or 10 minutes how to sell it quickly. I think the best demonstration to make to a customer, one that will make him impressed and then want to learn more and lead you perhaps into some of the more complicated things which we can help you with. When the instrument's ready to operate, it shows a Poincare sphere. So for this demonstration, take a jumper cable that's provided with the demo and hook it from the output of the laser to the input of the PSG, the polarization state generator. Connect another fiber optic cable, one without cladding and protection, to the output of the generator, the input of the analyzer. It's important that you use basically a bare piece of fiber for the second cable, because we're going to press on it, apply pressure to it, and create very small PMD effects. If you use a jumper cable, it won't be anywhere near as effective. Take the mouse, go to the opening screen, and under the Setup tab, you want to turn on the laser. The laser source menu will come up. Turn on the laser, and then pull down the measurements menu. There are 5 choices at the top of the measurements menu, and select either the PMD, PDL, Mueller matrix, or Jones matrix. Either of those top 2 will be fine. We're using the Jones matrix for this demonstration. You'll then get another laser setup, and then allow you to select which frequencies we're going to use in the scan. And the easiest thing to do is just to scan the entire width of the channel. So your setup will be from start channel 1 to 96. And you might choose for a step size 5 steps, which is 0.25 terahertz. That makes for a nice display. Press OK, and now you see the screens that show on the top graph PMD as a function of frequency, and the bottom graph second order PMD as a function of frequency or wavelength. The boxes at the bottom we're going to select, so to show on the graph second order PMD, that's the left box, and then in the other boxes we're going to select the average value. So we're going to want to see the average PMD value at the bottom. And press start. You can do this for a few times to let the customer see that we're quickly scanning with our internal laser this piece of fiber and measuring its PMD characteristics. He might ask, can I use my own laser? And the answer is of course, and you can buy this unit without an internal laser and save a few dollars. If you haven't already explained the internal crystals and how the crystals work, this is a good time to differentiate this product from some of the Agilent products that use the lithium niobium oxide technique. Go back to the sales newsletters that you received and point out that this is a completely digital instrument. It's a unique instrument. It uses a patented technology using digital crystals, and because they're digital crystals, by applying a small field they toggle, and so we don't have to have complex analog circuitry controlling the polarization. It allows this instrument to be more accurate, higher resolution, less expensive to build than anything from Agilent. And now the next part, we're going to show the remarkable resolution of this, which surpasses anything else on the market. In fact, the accuracy of this is so high that it's almost impossible to calibrate, because there are no standards even at NIST that offer a significant gain over the accuracy of this instrument. To do the resolution part, invite your customer, first coil up some of the fiber, and invite your customer just to place his hands upon the coil and press down while it's scanning. If he does so, what you'll see is the scans actually move up and down in responding to the pressure from his hand. If you look at the scale on this, what you'll be able to say is that you're able to resolve PMD changes and second order PMD changes on the order of 0.01 picosecond and 0.01 picosecond per second. Underscore that to the customer, because there's simply nothing else on the market that can resolve these small changes in PMD. And so we come to my favorite part, the trial close, because we can review for the customer, are you looking for a general purpose instrument to measure PMD, first order and second order, to a high degree of accuracy, to a high degree of resolution, with its own internal laser or without an internal laser? If that is of interest to you, this product, the General Photonics PSGA, is by far the best solution on the market.